Okay, so to conclude this section, I want to graph some absolute value functions, show you how to graph these. Okay, let me write back up. So there's going to be, remember, if there's no number behind the x, you start at 0. Absolute value of 0 is 0. Absolute value, remember this is the same thing as y. Absolute value of 1 is 1. Absolute value of 2 is 2. So you've got 0, 0, 1, 1, and then 2, 2. This is V-shaped. So it's going to go this way. Now it's straight. It doesn't bend. Okay. Now, to get the other half, you need to come back over here and put 1 point straight across from this one, and then come right over here, come 2 over, and there'll be a point right there as well. So there's that V shape. Now, what I'm about to do is ask you to graph some of these that open, where it's shifted. So let's graph this one. So y equal to the absolute value of x minus 3. Okay, so we're going to make an xy chart. And remember I told you, it's good that you know this. What is this going to do to that graph there? What happened? I replaced the x's with x minus 3. So I took that x away and put an x minus 3. So if you replace x with x minus 3, it's going to shift your graph 3 units opposite to the right. So this V shape is going to be over here. Now, you're going to see that once we do this. All you've got to know, if you don't understand anything what I just said, is how do you pick the first number? Well, if there's x minus a number in here, you take the opposite of it, so it's 3. If that's x plus a number in here, if this is x plus 3, this would be negative 3. If there's no number in there with the x, it's always 0. Now, what do we do with the V shapes? We pick one more, and then I like to pick one more. You don't have to, but do remember that it's V-shaped. All right, plug in 3. 3 minus 3 is 0. Plug in 4. 4 minus 3 is 1. The absolute value of 1 is 1. Plug in 5. 5 minus 3 is 2. Absolute value of 2 is 2. So you're not squaring it or square rooting it. You're just taking the absolute value of it. So when you plot these points, 3, 0 is here. 4, 1 is here. 5, 2 is there. There's that part of that V shape. Now, come back 1 and there's a point straight across from there. Come back another and there's a point straight across from there. So 1 back here, 2 back, straight across there. And you can draw in the V shape. So, what is the difference between this graph and this graph? This graph, if you shift it 3 units right, you get this graph. Okay? All right, let's talk about what this is going to do, and even if you don't understand it, I'll still show you how you can graph it. This is an absolute value function. It's V-shaped. Now, what does this do? Okay, is there a number in here with the x? No. So there's not going to be a shift left or right. So the first x number is going to be 0. What's this number on the end do? It subtracts 3 from all of your y values. So if you're subtracting 3 from all of your y values, that's down 3. So this is going to be a V-shaped graph that's not shifted left or right, but it is shifted down 3. 1, 2, 3. Now, what's this number going to do? It affects the width of it. I'm not sure exactly how. Let's find out. So, if you didn't understand anything I just said, do this. Make an XY chart, and the key is your first number. If there's no number in here with this X, it starts at 0. Then go to the next one, then go to the next one. Now, I don't do that with the radical function because if you go 2 past it, you can't get the square root of that number. And remember, the radical function is half of a U shape. This is a V shape. All right, let's plug in 0. What's the absolute value of 0? 0. Then you have to multiply. 0 times 2 is still 0, and 0 minus 3 is negative 3. Now let's plug in 1. Absolute value of 1 is 1. 1 times 2 is 2. And 2 minus 3 is negative 1. Now let's put in 2. What's the absolute value of 2? It's 2. 2 times 2 is 4. 4 minus 3 would be 1. Okay, so let's draw this graph. Zero, negative 3 is right here. 1, negative 1 is right here. And 2, comma 1 is right here. V shape goes, sorry about that, goes up through here. Now, come straight across from here, and there should be 1 right over here, directly on the other side. This is the middle. This is 1 unit away, so go 1 unit here. Now this is the middle. This is 2 units away, so come 2 units back this way. If you're freehanding it, it just makes it easier to draw the other half of the V shape by doing that. So these 2 points should be straight across from each other, and these 2 will. Now, you could do this. You could take negative 1 and negative 2 and plug these in, but you're going to get those 2 points. So there's your V shape. Now, this appears to have done 2 things. First of all, did it shift? This is what we call your vertex right here. It's the first time you've heard me use that word. Your starting point on your V shape, that at that end of that V, that's called the vertex. The vertex is at 0, negative 3. 0, because there's no number behind here, negative 3. 0, negative 3. That's the vertex. Now, what did this number do? If you'll look at this V shape compared to the parent one's like this. This V shape is like this. It's a little skinnier. So, what does this number right here do? The bigger it is, your V shape gets skinnier and skinnier and skinnier. Now, that's just the opposite of what happens with this number in the radical function. In the radical function, this number getting bigger and bigger makes your half U be wider and not skinnier. It's just the opposite effect. But you don't have to know any of that. It'll take care of itself if you know what number to put right here. All these other numbers come from. Once you get that one number, all these others fall into place. Okay? So let's look at another one then. Now, let me say once again what you should know based on what I've told you from this graph. It's okay if you don't put it all together because you can still work the problem. I'll say that again in a minute. All right, so what do I know? This is an absolute value function. What does that mean? It's V-shaped. The vertex for the parent function is at 0, 0. but it's not going to be here. All right, so let's see. If this were just the x, it would be 0. So this is x plus 1. So what does that mean? 1 to the left. So your vertex now is not going to be at 0, 0. It's going to be at -1, to the left 1. Now, what does that number do? It adds 3 to all of your y values. So the number on the end is a vertical shift. So it's going to be 1 to the left, 3 up. So the vertex is going to be at -1, comma, 3. To the left 1, and well, to the left 1, up 3. I'm still teaching as if you're looking at me in the classroom. All right. Now, what's this number going to do? It's going to make it skinnier. What do you think this is going to do? Remember what that negative did a while ago is inverted it. So where normally this negative, when you did half of a U, it looked like that. That negative inverted it. So if you've got a V shape that goes up, what do you think a negative does if it inverts it? It's going to make it go down. Is it still a function? Yes, because it passes the vertical line test. So this number is going to make it skinny. That negative is going to invert it and make it go down. Now let me say once again, you don't have to know any of what I just said there if you know how to pick your numbers in your XY chart. And the first one is the most important one. Okay, so we're going to do this last one, make XY chart. All right, I've said this multiple times, but I'm going to say it one more time. Look at what's inside the absolute value, x plus 1. Take the opposite of that, so it's going to be -1. So that's the first number. Now, if that was x plus 5, this would be -5. If it was x minus 4, this would be plus 4. X minus 8, plus 8. If it's just x, this would be 0. Now, which way is it going to open? This right here, remember I said it's going to make it go down. If that's positive, it's going to make it go up. All right, now, that's the only number you got to know how to get. Now, how do you get to the next one? You add 1 to this. So go to 0, and then do one more, add 1 to that. I just like doing 2 more to get a good V shape. You don't have to do but 1 if you don't want to. You just need to remember how to draw the V shape. Okay, now how do we find these? You plug these numbers in. So, -1 plus 1 is 0. The absolute value of 0 is 0. 0 times -2 is still 0. And 0 plus 3 is 3. Now plug in 0. 0 plus 1 is 1. Absolute value of 1 is still 1. 1 times -2 is -2. And -2 plus 3 is plus 1. One more. Let x be 1. 1 plus 1 is 2. Absolute value of 2 is still 2. 2 times -2 is -4. And -4 plus 3 is -1. So, let's plot this. Now remember, I said a while ago, the vertex, the opposite of this, -1, comma, and this right here is up 3. So that should be my vertex. It is. Look at your first point. If you plot -1, 3, that's to the left 1, up 3. Now, 0, 1, right there. And then 1, -1, is right there. Now, you've got to know where to put your pencil to start. You always put your pencil on the vertex. So you're not putting it down here. You're putting it up here. That's the vertex. So you put your pencil here and go straight down through there. Now this thing's going to go down. This is your center line, if you will. So this point is going to be straight across, 1 over. And then this point is 2 units from your center line. So you got to move 1, 2 over here. So the way you get the vertex is you simply take the opposite of this number, comma, whatever this number is. And if there's no number out there, vertex would be 0. But that first point is always your vertex. Okay, so that concludes this section, graphing radical functions and absolute value functions by first of all using the parent function. A radical function is half of a U-shape. It'll either be the upper half of the U-shape or the lower half of the U-shape, bottom half, depending on if that number is positive or negative. Absolute value function is a V-shaped with a vertex at the origin, but if you have a number behind that X in there with the absolute values, that shifts your vertex horizontally, the opposite of that number. And if there's a number added or subtracted behind the absolute value, that shifts your vertex up and down so many spaces. So that concludes this section on graphing radical functions and absolute value functions.